All right, we're going to take a look at problem number 30. Now, I got to admit to you, I'm a little shaky on this one, so don't hold it against me if you get lost. I'll do my best. So, how many ordered triples of positive integers a, b, c have a greatest common factor of 2020 and a least common multiple of 2020 squared?
Okay, might mean he's ready to mate.
Maybe. Thank you for sharing that. Now, who doesn't want to talk about meeting bearded dragons on a video?
I don't know.
Neither do
Gotta
I.
keep the people entertained.
I know, right? So, sorry about that side conversation. Hopefully you found that interesting. Now, a ordered triple is simply saying we have three numbers and the order that each of the numbers is in matters. So if we have 1, 2, and 3, that's different than 3, 2, 1. All right, that's not too bad to understand. And then we're looking at greatest common factors and least common multiples. Well, to do least common multiples and greatest common factors, we are definitely talking about prime factorization. So, I know that 4 goes into 2020 because 4 goes into 20, and it goes in 505 times. So 4 is 2 squared. This can be broken
allows him
into
to dissipate extra
5
body heat.
and 101. And so if I look at 2020 squared, it's just going to be this number squared. So we have 2 to the 4th times 5 to the 2nd times 101 to the 2nd. So first things first, this is a problem about exponents. So we really only care about the exponents at this point, and we know that we only have 3 factors, which means we have, this kind of contains the number of possibilities. Now for the 2, we can have a 2 that is either 2 to the 2nd, 2 to the 3rd, or 2 to the 4th. For the 5, it's either 5 to the 1st or 5 to the 2nd. And for 101, same deal. We either have 101 to the 1st or we have 101 to the 2nd. Next, the next thing we need to worry about. All right, so let's take a look at what we're looking at. So we have 3 letters. We have 3 letters. We have A, B, and C. So that means we have 3 different positions that we can put things in. So we're going to be looking at a lot of triples here. So what I'm thinking right now is, all right, so for this number to work, I'm going to have at most, at least one exponent that is the largest of its kind, and at least one that is the least for each of my numbers. So again, we're talking about 3 numbers, A, B, and C. So what I'm now going to do is I'm just going to look at the factor of 2. I'm going to look at the factor of 5 separately and the factor of 101 separately. All right, so I know that in A, B, and C, each of these numbers has to have a factor of 2, a factor of 5, and a factor of 101. I know that to be true. So in other words, A is going to be 2 to the 1st plus some other number that is 1, 0, 1, or 2. And I'll call that extra number x. And then it will also have 5 to the 1st plus another number, let's call it y. Oh, sorry. Keep this. Let's call this one x as well. And then we'll also have another number. Let's call that x2, because x1 and x2 may not have to be the same thing. And we also have 101 to the 1st plus x to the 3rd, which means b is going to be 2 to the 2nd plus a number. I don't know what that number is, but it's either going to be a 0, 1, or 2. Call that x2. Sorry, call this y. I'm trying to, this makes sense in my head. It may not make sense in the video. I'm just simply stating that we have 3 sets of numbers. So, this is the best way to think about it. So we're going to have 3 sets of factors of 2. you're going to have a factor of 2 in your A value, a factor of 2 in your B value, and a factor of 2 in your C value. That's the best way to think about it. Okay, so that's what I'm going with. Which means, in our A value, so we're looking at our A, B, C. So we have our A, B, and we have our C. So I'm just looking at factors of 2. So that means if we have at most a 4 and at least one 2, I can have a 2, 2, and a 4. So my A number has a factor of 2 to the second, my B number has a factor of 2 to the second, and my C number has a factor of 2 to the fourth. Well, how many ways can I scramble this around? Well, I can go 2, 4, 2, or 4, 2, 2. So this has 3 different ways of doing it. Well, remember, I can have 1, 2, I can have 1, 4, but I could also have a 3 in there. So my A value has a factor of 2 to the second power, my B value has a factor of 2 to the third power, and my C value has a factor of 2 to the fourth power. So I can scramble these around, and I can get 6 different ways because there are 3 numbers that can go here, 2 numbers that can go here, and 1 number that can go here for a total of 6. 6 different ways of having an A with a factor of 2 to the second, B 2 to the third, C 2 to the fourth. So then, I can also have, do A, B, and C again. So I can have 4, 4, and 2. I can have 2 4s and 1 2. That's going to have the same number of possibilities, so that's 3 total possibilities. So right now, how many different ways can I scramble the factor of 2 for my A, my B, and my C numbers? 3 plus 6 plus 3, which is 12. So my 2 has a 12 different ways of organizing the factor of 2. So then, we have to take a look at the 5. Now the cool thing about the 5 and the 101 is that they will have the same number of ways of scrambling their factors. So really, I only have to figure this out for 1, and then just double it, and I'll be in good, well, just use that number for the 101, I'll be in good shape. So here we go. I'll change my pen color to you. All right, so for the 5, so this is factors of 5. I can have my A value with a factor of 5 to the first, so that's an exponent of 1. And my B value, 1, and remember I have to have at least one that is the largest exponent, so we have a 2. Well, how many different ways can I scramble this? Well, I can go 1,
Let me
2,
guess 6.
1. Nope.
12?
Just hold on a second. It is 6. 2, 1, 1. Well, I could also have 2 2s and 1 1. And so I would just rotate it here. So here we have 6 different ways of organizing the factors of 5. Well, we're going to have the same scenario for the factors of 101. So we have 6 different ways to organize the factors of 101 for my A, my B, and my C values. Well, now all I have to do is multiply them together. So 12 possibilities times 6 possibilities times 6 possibilities is a total of 432 ways, or in this case, numbers, or ordered rows. That wasn't so bad.